All right, question number 2. This is also on page 386, 5.12. And let's read the problem. 3 machines, A, B, and C, are used to produce a large quantity of identical parts at a factory. Machine A produces 60% of the parts, while machines B and C produce 30% and 10% of the parts, respectively. Historical records indicate that 10% of the parts produced by machine A are defective, compared with 30% for machine B, 40% for machine C. Suppose we randomly select a part produced at the factory. Find the probability that the part is defective. Now, the book doesn't say to do a tree diagram, but in this case here, when you have one thing leading to another, a tree diagram is going to be super helpful. So let's think about what we have. First, we have three machines. They're going to make a part, and we'll call it A, B, and C. Part A is 60%, so that's going to be 0.6. Part B and C both produce 0.3 and 0.1. So those are your percentages from the given information. Then historical records indicate that 10% of the parts produced by machine A are defective. So you have defective, and that means the other one would be works or not defective. So 10% of the parts produced by machine A are defective, so 0.1, which means this would be 0.9 because these two got to add to 1. And so we do the same thing here. For machine B, it's or 30% for machine B, so 0.3. That means this is 0.7. And then for the last one here, we have 40% for machine C. So 0.4 and 0.46, defective and not defective. So we want to know the probability that the part is defective. Well, it could be defective from any of these 3 machines, right? So the probability of it being defective from machine A, well, that's going to be 0.6 times 0.1, which is 0.06. The probability of it being defective from machine B, that's 0.3 times 0.3, and that should be 0.09. I always have to second guess myself on those decimals. But yeah, it's 0.09. And the probability of being defective from machine C is 0.1 times 0.4. So that's going to be 0.04. So these are all your defective. Now, symbolically, that looks like this. The probability of A and defective is 0.6 times 0.1. Probability of B and defective, again, same multiplication. And the probability of C and defective, so now that we have all those, the question says the probability that the part just in general is defective. That's or, could be from A, B, or C. So we'll want to add these together. And overall, that's going to be your total. So 9 plus 6 is 15, plus 4 is 19. So that should be 0.19. So the probability of defective in general is going to be 0.19, 19%. Pretty terrible stats if you think about that. But see how that tree diagram can kind of be useful in this case. So now letter B, if the part is inspected and found to be defective, what's the probability that it was produced by machine B? So now we can go back to our tree diagram and we can follow the path for machine B, and we see that that one's 9%, right? 0.09. Well, we already have the probability of it being defective as 0.19. So this is essentially the same thing as saying, what's the probability of being of machine B given it's defective? And that means we're going to find the probability of B and defective. and divide that by the overall probability of it just being defective. While being defective, that's 0.09. So that's going to be 0.3 times 0.3 if you want to put that work again. And the just defective, well, we already calculated that, that's 0.19. So again, that's just going to be that denominator down there. So it's essentially 9 divided by 19. So about a 47.37% chance of, if you have a defective part, it was from machine B. So to summarize that, we would say if a part is found to be defective, the probability of it being from machine B is 0.4737. And that's all you got to do on that. So thanks for watching. One more question.